Last Thursday, we started chemical reactions and we have done two properties. It is reaction with acids and alkylation. Okay? Now, in this alkylation, I have a question. Question is, while preparation of what's the name of this? And dimethyl 4-nitro aniline. From aniline, the alkylation is done. Done ahead of nitration. Okay. So why you do not do first nitration followed by alkylation? Please remember. If you first, this reaction we will do later on. See here, if you carry out nitration of aniline, that will do in detail. I should write nitration. I will not write anything else. Okay. If I do nitration, then if I do this methylation, the methylation will not occur. Methylation of nitrogen cannot be done. Why? Because nitro group is a strong electron withdrawing group. It will reduce the nucleophilic character of nitrogen because the lone pair of the nitrogen will be drawn inside. So what we do? First we do the methylation, then we follow nitration. After that, if I want to do this, this will not occur. For what we should have to do? First we could do here methylation, then if you do nitration here, then only you will get the compound. Please remember. I'll give you the question. If you do, then only it is going to have here, this is not going to form this compound. It is, if we introduce an electron withdrawing group into the phenyl ring, it will deactivate the nitrogen towards nucleophilic substitution reaction because of the electron withdrawing effect, minus effect or minus R effect. Now we'll do acylation. Acylation means reaction with acid chlorides. Reaction of amines with acid chlorides are done in presence of a base. Then what base we take? Pyridine. This is pyridine. Pyridine is organic base. To form corresponding acetamides. So if you have taken a primary amine, okay, then in that case, see here, this reaction is very extremely spontaneous. So what we will get now? You get AC. All right. If you have taken a secondary amine, so you get here now a secondary amide, and you get here tertiary amide. Write down. Now we'll do with example, huh? So we have taken here So what is the name of this one? This is amine. Okay, the name of this one is N-phenyl acetamide. Aniline acetyl chloride, N-phenyl acetamide. And dimethyl acetamide. Don't pay. Now, if you do it, benzoyl chloride. This is called benzylation. Amines react with benzoyl chloride. See, this is first reaction we have done with aliphatic acid chloride. This is with aromatic acid chloride. Benzoyl chloride. How does benzoyl chloride looks like? With benzoyl chloride. In benzoyl chloride, we do not use pyridine. Or you can write also. In presence of dilute solution of sodium hydroxide. or pyridine. You can write. But generally, you do with dilute solution of sodium hydroxide to form corresponding benzamides. Okay? Now, गुड्डू देखते কি হয়েছে गुड्डू দেখো কুত্তা ডাকছে কেন কি হলো স্নুপি স্নুপ okay class AC. Okay, what's the name of this one? This is N-phenyl benzamide, or it is more popularly known by its common name. This we call it benzamide. See, if it is CH3, there were already we have written na CH3 CONH phenyl. We have written N-phenyl acetamide. Please below that you write there acetanilide. There I forgot to write acetanilide. Sometime in exam this name comes. So if you do not get introduced with this name, then you will have problem. When we have done with the acetyl chloride, CH3CONH phenyl na, with an N-phenyl acetamide, below that you write acetanilide. Can I rub this portion?
Yes, sir.
Then we write your note. Finish writing. One is important. In acylation and benzylation of amines, bases are used to neutralize HCl produced in the reaction. Otherwise, try to understand. Otherwise, HCl will react with amines which are basic in nature to form corresponding to form salts. By this way, lot of amines will not participate will not participate in the reaction. Because once it forms salt, then they will not going to react. Will not participate in the reaction and yield of the amides will be less. Now we'll continue this one. In benzoylation, dilute sodium hydroxide is used, and such method of reaction of amines with acid chloride is called Schotten-Baumann reaction. The technique is called Schotten-Baumann reaction, not that reaction. Okay? So, let me write the example again. See here. Now, you will not get HCl immediately react to sodium hydroxide to give you what? NaCl and H2O. So, it is not going to react with HCl is not going to react with amines. So, this method is called Schotten-Baumann reaction. Second, first I'll explain, then I'll write. Unlike alkylation, repeated acylation of amines does not take place. Okay, let me write here now. Does not take place. To give you this does not take place. But in case of alkylation, we have found one after another you can carry out alkylation. You react with methyl iodide, then you will give N-methyl. Again you react, you will get N-dimethyl. Again you react, then you get a salt. So in case of acylation, this does not take place. So why it does not take place? Let us see. Okay, I'll write this portion later. So let me show. See here. This carbonyl group is a very strong electron withdrawing group. Okay. So it is strong electron withdrawing. What is going to happen now? Here. In that case, what you get here? See. Your nitrogen does not have any electron. If the lone pair is missing, then it cannot act as a nucleophile. Okay, so we'll write now here. This is because the carbonyl group present in this is amide. Present in amide is a strong electron withdrawing group, and it decreases the electron density of increases the electron density on nitrogen atom. And so further acylation does not occur. So this is important for exam. Why further acylation does not occur. So you draw the region and then explain. So it pulls the electron from the nitrogen, by which nitrogen is deactivated towards nucleophilic substitution reaction.
Done, sir.
Okay. Now we'll do a similar reaction now. We have done reaction with acid chloride. Now we'll do reaction with sulfonyl chloride. Sulfonyl chloride, you see acid chloride, we get it from carboxylic acid. And sulfonyl chloride, we get it from sulfonic acid. So we'll write now. Reaction with benzene, sulfonyl chloride. How does it look like? See here. This is sulfonic acid. Okay. Like carboxylic acid, if you react with thionyl chloride, you get acid chloride. This one also, if I react with thionyl chloride, phosphorus pentachloride, phosphorus trichloride, I will get okay. So this is important for example. We'll do one by one. First you see, then reaction with primary amines. Okay. So what is going to happen? It will go. So what you are going to get here? When we react with acid chloride, we get amide. This is also an amide, but amide of sulfonic acid. So we call them as sulfonamide. Okay. So it's one maybe alkyl group or aryl group. So I'll write now here. Then alkyl or aryl benzene sulfonamide. Okay, this is a white. You get a white precipitate. All right. Now I'll leave some space. Wait. First, we try to understand. B. Reaction with secondary amines. So here also you are going to get see here you have one hydrogen, here you have two hydrogen, no hydrogen. So what will be the name now here? This is also a white precipitate. You get this is called NN dialkyl or aryl benzene sulfonamide. Okay. Sorry. So some space is there. Now I'll write here C. So reaction with tertiary amines. So you write here tertiary amines do not react with benzene sulfonyl chloride due to the absence of, see, from here HCl is going out, HCl is going out. Tertiary amine does not have any hydrogen. Absence of any replaceable means what? The hydrogen which goes out. Replaceable hydrogen atom. So,
Excuse me, sir.
yes.
Sir, there is it due to the absence of any replaceable hydrogen atom?
Yeah, due to the absence. Okay, see here, no hydrogen. So the reaction does not. Okay, so this is a liquid. If this is also a liquid, what will get here? What will write now here? No precipitate. Okay, now you write. Okay, you leave some space, right? No, I'll finish it now. See here, now what I do? Do that. So in primary, you've got a white precipitate, secondary also you've got a white precipitate. Now to that, if I add here sodium hydroxide or potassium hydroxide, see, this nitrogen is bonded to sulfur with 2 oxygen. So it's a very strong electron withering in nature. So this nitrogen-hydrogen bond becomes highly polar, that is, it develops H plus and sodium hydroxide picks it up. So once you add sodium hydroxide, white precipitate dissolves because it forms a salt. So what you are going to get here? And we get here. So we write now here, white precipitate dissolves. All right. Now you see in this case no hydrogen. So if you add sodium hydroxide, no reaction. Okay. If I add here sodium hydroxide, no reaction. This is what I should write now here. White precipitate reacts. So this is a very wonderful reaction. See, with this benzene sulfonyl chloride, we can distinguish which amine is primary, which amine is secondary, and which amine is tertiary. Suppose I have been given 3 bottles which are not labeled, but I have been told that here 3 types of amines are there: primary, secondary, and tertiary, and please find it. Then in 3 test tubes, I will take this liquid amines. And in all the 3 test tubes, I'll dropwise I'll add benzene sulfonyl chloride, which is also liquid. All right. So in one of the test tube, there will not be any precipitate, and that is tertiary. No precipitate. So immediately we could identify the tertiary. In other 2 test tube, white precipitate will be there. So in both the test tube, we'll add sodium hydroxide dropwise. The test tube in which you find the white precipitate dissolves, that is primary, and the test tube in which the white precipitate is retained, and in that case, that is secondary. Write down. Okay. What is the heading? Reaction with benzene sulfonyl chloride. Then write A, then B, then C. This is important for exam.
प्लास्टिक भी चलते लगा वो भी कैसे में चलते हैं हां वो भी खेले तो वो जो बांधा से नहीं वो भी खेले ना प्लास्टिक से तो बेटर मशला उसका खाओ ये तो पहले ना आपने
ওটা রান্নাঘরে রেখে দিয়ে গুড্ডু ও দিদি ইসে ফেলবে
हां ओके पोर्टल आईडी
না না বাইরে খাম না গুলো আসলে ময়লা ফলানো দিন না
হ্যাঁ বাইরেই তো বসে এখনো ময়লা পড়েনি
ও হ্যাঁ
এখন শুধু কোনো কাজ শেষ হয় আজকে বুঝছো পটল দিয়ে আলু ফেলে দেয় তো আলু একটা দিলে দিও আর পনির রেখেছি পনির দিয়ে পটল দিয়ে এড করবে আর এখানে চার কুমড়া ডাল দিয়ে রেখেছে একটুখানি কেটে চার কুমড়া খাবে অল্প করে করবে আর কুকারটা ভরাতে রাখবো না কুকার ভরে না ঠিক আছে না ওটা রাখবো তাহলে একবার ইয়ে করে
রাব
Yes, sir.
So now we'll write here, note. This reaction is used for the distinction of primary, secondary, and tertiary amines. And is known as Hinsberg test. Benzene sulfonyl chloride is known as Hinsberg reagent. So, what you can write now? Example. Primary amine plus, I'll just write briefly. I'll write like this. So it's easy for you to write. This we'll write now here C6. No, I'll write ulta. I don't know which one will be comfortable for. So I do all the changes. Right now here, Hinsberg reagent. So it will give me CCH5 SO2 NHR. White precipitate. Sodium hydroxide. Then we will not write any product here. Okay. C6 SO2 N N right here sodium R. Right now water soluble. So you know this primary agent. Second, pisanan lagi hendak kau. Kan kau itu orang sudah kali. So, white precipitate. Sodium hydroxide. No reaction. White precipitate remain undissolved. Then no reaction. So this is a summary.
So, in reaction with primary amines, what is that last product? That water's label C6H5S2, then N, what is that on top of N?
Sodium, Na.
Ah,
Here you write minus and here you write plus.
Done, sir.
Okay, that D. Note, that this reaction is also used. No, don't write this reaction, right? Benzene sulfonyl chloride. Benzene sulfonyl chloride is effectively used for the separation of mixture of amines. Not only you can distinguish, we can also separate them. mixture of amines. And is known as Hinsberg method. Hinsberg method. So it is a chemical separation that you can do in a laboratory if the amount of the amine is less. But if it is a large amount in industry, we separate by fractional distillation. Okay. So this is very, very important. Suppose they ask you, how can you distinguish between primary amine and secondary amine? You write by Hinsberg reaction or Hinsberg method. Because primary amine, the white precipitate it will give, it will be dissolved in sodium hydroxide. Secondary amine, no. If they ask you, how can you distinguish between secondary and tertiary amines? You write by Hinsberg method or by Hinsberg reagent. Because tertiary amine will not give you any precipitate, secondary amine will give you precipitate. In that case, you need not add sodium hydroxide. All right? Done. Anyway, this is not being mentioned in a book. Okay?
Done, sir.
Now we'll go for a very, very important reaction for exam point of view. It is called, I don't know, what will be the, this one? 5 or what? I think 5. Carbylamine reaction. When both aliphatic and aromatic primary amines are heated with chloroform in ethanolic solution of potassium hydroxide or sodium hydroxide produces an extremely foul smelling, very bad smell, foul smelling substance called carbylamine or isocyanide or isonitrite. Okay, I'll write now. Yeah. R can be aromatic or aliphatic. This is chloroform. Why I'm writing, you will understand. Here we do not add water. So here ethanol is used as a solvent. In your book they may not give you, I don't know that. Okay? See here, when you heat it, 3 molecules of HCl is liberated. And they react with 3 molecules of potassium hydroxide acid base reaction. First it will be liberated, then it will react. So what you are going to get? You will get here. Actually you get like this. Okay? But it is not given in your book, so please don't write. So I'm little scared of your school. Look at this. This is called carbylamine. Carbylamine. Or we call it isocyanide. Okay. All right. Now you will do 2 reactions. You do the same reaction with ethylamine. So here you write here ethylamine. And one we do with aniline. Okay. Same reaction, exactly same. You write the product. This is ethylamine and this is aniline. Name of the product will be ethyl isocyanide. Here the name of the product will be phenyl isocyanide. Do. Finished?
Yes, sir.
Okay. I'll do one reaction now. It is not in your book. But it is, we have already done it aldehyde ketone chapter. Okay. So reaction with aldehydes and ketones. That you know, we've already done. So if we have reacted with primary amine, what you get here? You get here that we have already done. What you call them? We get here imine. So it will be imine of aldehyde or imine of ketone. Now, if you have done this reaction with aromatic aldehydes, say you have done with this aniline. And this is aniline. You have to add here, you have to add in presence of dilute acid. See, what you will get here? This. These are not at all difficult. I don't know why in your book these are not being included. I'm very sad for this one. It will be always trans. Okay. See. These are called Schiff's bases. They are called Schiff's bases. ও না বাসার সামনে আইছে না a secondary amine. Okay, this I have shown you also. Suppose I have taken a ketone and I have reacted with a secondary amine in presence of HCl gas. It should not contain any water in this case. What is going to happen now? See, first it is the addition reaction. Now, in secondary amine, you do not have any hydrogen. So, what will happen now? In this case, this beta hydrogen will undergo elimination reaction. That you know, beta elimination reaction. I have given you only for this, for your entrance exam. These are called enamine. For double bond in and for amine is amine. Okay, up to this much today. So we'll meet